Here is the next example. In this example, we're finding state equation, output equation for a transfer function by using the Jordan form. So here you can clearly see it's a white triple dot. So it's a third order system. Okay. So when I write the equation y over u, which is 1 over s cube plus 2s square minus s minus 2. Okay, that's the given transfer function. Y by u equal to, that's the given transfer function. The only positive thing here, he clearly mentioned it has a pole at -1. As I mentioned, this is called characteristic polynomial. Okay, this is called characteristic polynomial. When I make it equal to 0, that's called characteristic polynomial equation. That characteristic polynomial equation represents the number of poles, or represents the poles, not only number of poles, represents the actual poles of that given system. Now, so for sure, the order of the system will give you number of poles. This system has 3 poles, and he's saying one pole is at -1. So one pole is at -1, so that is s equal to -1 or s plus 1 equal to 0. We need to find the remaining 2 poles. Usually if we have 3 poles, for sure I'll give you a third pole. If I don't give you third pole, probably you need to find the first pole by using trial and error method, by substituting s equal to -1 plus 1 minus 2 plus 2 minus 3 plus 3. Most probably one of the pole is going to be in anywhere in there. Okay, so now I need to find the remaining 2 poles to continue with this example. So to find the remaining 2 poles, what I'm going to do, I'm going to do the long division. So if I do the long division, s cube plus 2s square minus s minus 2, I'm dividing this with s plus 1. So I'm going to multiply this with s square. So s cube plus s square. So it's going to be s square minus s plus s. So that's going to be s square plus s. That's going to be minus 2s minus 2. So I'm going to multiply this with 2. With minus 2. So I'll end up with 0. So basically what I can do, this y by u equal to 1 over, I can write this as s plus 1 and s square plus s minus 2. Okay, that's what the second one is, or the remaining 2 poles are. Okay, so can I say this as, I can write this as s plus 2 and s minus 1. That's also, I found that by using trial and error method. Okay, so 1 over s plus 1, s minus 1, s plus 2. Okay, those are the 3 individual poles. Now I'm going to find 3 individual terms, a over s plus 1 plus b over s minus 1 plus c over s plus 2. Okay. Now to find a, I'm going to use the substitution method. A equal to, take the whole equation other than the denominator of a and substitute s equal to -1. So if I substitute -1, 1 over minus 2 times 1, so a equal to -1 by 2. That is my a. Now I'm going to find b equal to 1 over s plus 1, s plus 2, and substitute s equal to plus 1, s equal to plus 1. So b value 1 over 2 plus 2 times 3, b equal to 1 over 6. Then c equal to 1 over s plus 1, s minus 1, substitute s equal to -2. then c equal to 1 over minus 1 minus 3. So c equal to 1 over 3. Okay, now I have all the individual terms. So y over u equal to minus 1 over 2 s plus 1 plus 1 over 6 s minus 1 plus 1 over 3 s plus 2. Okay, now I'm going to draw the simulation diagram. So I know 1 over s plus 1, can write this as, remember one important point, if I have plus 1 here, this is going to be minus. So this is for 1 over s plus 1. Same way I'm going to write 1 over s minus 1. Since I have minus there, this is going to be plus there. And then 1 over s plus 2. Okay, now these constants, minus 1 by 2, 1 by 6, 1 by 3, as I mentioned, it's up to you. You can add those on the front side, or you can add them after at the output side. I mean, I don't know why, I always prefer to do it on the front side, but it's not going to hurt us any if we add it at the output side. Okay, so I mean, I already included minus in there, so this is going to be positive, this is also positive, that's also positive. Now y directly, you can add them directly without adding any extra blocks. Okay, now I have 3 state variables, so x1 dot, x2 dot, x3 dot. Okay, now x1 dot is nothing but minus x1 minus half u. x2 dot is nothing but x2 plus 1 over 6u. x3 dot equal to minus 2x3 plus 1 over 3u, and y equal to x1 plus x2 plus x3. That's y. Now if I write it down in the matrix format, a equal to minus 1 0 0, b equal to 0 2 0, c equal to 0 0 minus 2. Okay, now b equal to minus 1 over 2, 1 over 6, 1 over 3, and c equal to 1 1 1. Okay, and d equal to 0. These are the state equations and output equation of the given mathematical equation by using Jordan form. I'll stop it here. Thank you.